As we start to what I call find homes for electrons, we're going to have to find subshells that actually we'll find subshells to put electrons in according to the lowest n plus L rule. And N actually is something we've been talking about, that principal energy level N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4 as you kind of go up a ladder, up energy. Now L actually is the orbital type, and just to kind of remind you what orbital types we have an S type, we have with one box, we have a P type with 3 boxes or 3 orbitals, a D, and an F type. Okay, so those are the orbital types that we need to worry about as we find homes in subshells. So there actually, as it turns out, is a corresponding value to those subshells types. So if you have an orbital type that is an S, that literally has a numeric L value of 0. Not maybe so surprising, and it goes up from there. P has an L value of 1, D has an L value of 2, and F has an L value of 3. Just to make sure we're all on the same page, in part 4 we talked about an S-type orbital will have 1 box, a P-type orbital will have 3, 5 for a D-type. Just make sure we're all on the same page here. And what, 7? I'm going to run out of room here. 4, 5, 6, 7. 7 for an F-type. So when we have a subshell that has an N plus L value, I'll kind of show you what that would look like. Oh, before I go on. Okay. And I think I told you earlier, I don't know if it's on this slide, but if you do have an electron that is excited into a G-type orbital or an H-type orbital, then we aren't going to have to worry about this because we're always talking about electrons as they're in their ground state, but they would have an L value of 4 and 5 respectively. Okay, so hopefully this kind of rings some bells. Remember we said when N is equal to 1, it only has one type of subshell, and it's the S type, so 1s. When N is equal to 2, we have 2 possibilities, 2s and 2p. Kind of remember how that works? As I'm making this, actually, energy is increasing going down the page, isn't it? When N is equal to 3, we have 3s, 3p, 3d, okay, etc. And I think that's as far as I go. Now, I want to add a column here and come up with an N plus L value. So over here, I'm going to go N plus L. So notice that for the 1s, N is equal to 1 and L is equal to 0. So literally, the N plus L value of that subshell, guess what, is 1 plus 0. I get 1. For the 2s, we have N is equal to 2, L is equal to 0. So we have 2 plus 0 is equal to 2. So the N plus L value of 2s is 2. Does that make sense? Let me get some excitement here. 2p, N is equal to 2, L is equal to 1. So 2 plus 1, I got an N plus L value of 3. All right, so etc. 3s, N is equal to 3, L is equal to 0. So I got 3 plus 0, so N plus L value is 3. For the 3p, N is equal to 3, L is equal to 1. So I got 3 plus 1, I got 4. And the last one, here anyway, 3d, so N is equal to 3 and L is equal to 2. So I got 3 plus 2 is equal to 5. Great. So these are the N plus L values for these subshells. All right? Very good. Well, how those come into play then is that we are going to load electrons according to a subshell with the lowest N plus L value. Now, when that subshell gets totally full, then we're going to have to go to the next subshell, okay, the next lowest N plus L value. And if you go back to my previous slide, you're going to see that some of those actually had the same N plus L value. Like, goodness, we had, I'm kind of drawing a blank. Well, the 2p has an N plus L value of 3, and the 3s has an N plus L value of 3. And what this says is, if that's the case, we're going to go with the lower energy is the lower N. So in that case, 2p. So here in a little bit, I'm going to kind of break away from this lowest n plus L rule, but I'm going to come back and revisit it in something called the arrow diagram. And you'll see what I mean in a few parts from now. The arrow diagram is great at coming up with which subshell is the next lowest n plus L. So that kind of starting from the lowest energy and filling it up and going to the next lowest energy and filling it up and going to the next lowest energy, kind of going up like that, is actually called the Aufbau method of finding homes for electrons. It means Aufbau means building up. So one of the neat things, and you'll kind of see this as we start to do electron configurations, is that actually, how do I say this? If you know the electron configuration for instance, carbon, nitrogen is one more electron than carbon. All you have to do is take carbon and add one electron to it. That's kind of, you'll kind of see how that is as we go. But the lowest n plus L rule is going to be assigning n plus L values to these subshells, just like this.